Hi, just a short video from Koiro today, and this is not a video in my C64 series, although it's actually inspired by some incidents I had when I was filming and testing stuff. And I want to talk about this device here. That is my Mini Pro programmer from the XGecu Pro something company. And this is manufactured and marketed as an automotive programming device, and it has actually worked out pretty well. And I do think that this is an original and not a copy. If it is a copy, it's a very good copy because it has stood the scrutiny of customer support with their customer support line and also for some program updates. And I do believe that this unit actually has killed off a lot of 7406 devices during its lifetime, and I don't think it's devices themselves that actually have killed the chips, but I do believe that this has given a false reading and that users might have changed their 7406 chips when there was nothing wrong with them. And I will first go through the 74 logic devices with the 7406 and the other devices that have similar functions. So I will start with that to give you a bit of a background. First, what kind of chips we are dealing with here. This book is a book I hold in very high regard, and I'm going to take a bit of an introduction into the TTL series of logic before I start the real contents of this video. Back in 1987, I bought this book and I have read it from page to page several times. And this is one of the books that has taught me most when it comes to computer electronics and how things fit together. And although my original book is, I still have it, but the glue has starting to dissolve, so a lot of the pages is loose, and I have put this in a plastic wrapper to keep it safe. And together with these two books, and these are all books that was released early in the 70s, and I do think that the first edition of these is about 1973, 1971 and 1974. The TTL data book, I do think it was an earlier version, but not as comprehensive as this Bible. And my book was released in 1985, and there was a new release in 1988 and 89, I think, that used the newer IEC symbols inside the book. The contents of these books, I advise you all, they are available online, every one of them, and take a brief look through them. You will get a much deeper understanding of how the logic is coupled together in old retro electronics. To understand, really, to do fault finding in logic chips, you do have to understand some of the terms, and we usually call the high from 2.4 volt and up, and the low from about 0.9 volt something and down. There are some transitional phases to this, and there is also a timing factor. And here I have put the truth tables for all the basic logic gates. To get by in this video and to understand the topics, what you really need to understand is the high level, low level, and the off or high impedance state that is on an open collector circuit or a three-state circuit. What we are going to look into in this video is the simplest circuit of them all. It's the inverter circuit. And the inverter also have the simplest truth table, or the nearly simplest. The buffer have the simplest. A buffer is really a double inverter that goes through without inverting the signal. But if you put in a 0 here, you will get a 1. And if you put in a 1, you will get a 0. As simple as that. An inverter in TTL terms is really a simple device. It can actually be implemented with just a single transistor and a couple of resistors. With a high input here, you will get the transistor to open up, and it will pull the collector down towards 0. Then you will get a low out. So with a high in, you will get a low output on this circuit. And vice versa, if you put a low input, the transistor will not open, and the R value of the collector resistor will pull this towards VCC. And this is why you can't draw much power on the high state of a TTL output. Well, what is that anyway? It's a short from transistor logic, and it was actually the second widespread logic family out there, and it was made in the mid to early 60s, so it's really old technology. But this technology has evolved over the years, and there are a lot of differences. The original 74 series, you have the 74S, LS, the H, the HC, the HCT, the A, the ALS, and so on. So there is a lot of development that has gone on over the years. And today most of these chips is actually made of MOS technology, not TTL at all, even though they have remained their compatibility. And they replaced earlier logic. It was really a change in design, because earlier logic did not have a standard that defined one as a positive high 5 volt signal, or that 0 was 0 volt or something similar to that. ECL had this turned upside down, and CMOS luckily regained the levels from the MOS. But the original CMOS was a higher voltage series than TTL, and used from about 0 to 12 or 0 to maximum 15 volts or something. Today, this is of course true for most of these logic, and every one of these technologies are still used in some regard. But nowadays, the new 74 logic families goes from lower voltages, mainly 3.3 volt, but they are even available for lower voltages. As I said, we are going to cover the inverters in this series, and my main goal in this series is actually to show you how the MiniPro programmer actually handles this testing and what you get out of it. There really are a lot of inverters in this series, and I'm going to go through the main ones here. The 7404 is the most basic one. It's just an ordinary circuit with the ordinary totem pole output. And you have the 7414, which is actually almost the same, but it has hysteresis or Schmitt trigger interface that makes this keep a high and keep a low in a hysteresis curve. I have covered that in an earlier video before, but it's mainly a very good chip to make square pulses out of sinus or triangles or other stuff, or noisy lines. Then you have the 7405 with open collector outputs. And as you can see in these schematics, an open collector is that you have no resistor or anything that connects this to the VCC line. So you have to have an external circuit either connected to VCC, or you must have a pull-up resistor if you want to have out just the voltage. The 7406 and 7416 is also open collector outputs, but they actually allows you to do something that the 7405 does not. And that means that you can have a higher pull-up voltage connected here to a resistor than the VCC voltage. The VCC voltage still stays at about 5 volt, but on the 7406 you can actually have 30 volts of pull-ups here. So this can act as an interface to devices that needs a higher voltage to trigger relays and other stuff, or other logic families as the CMOS if you have 15 volt. The 1716 have maximum of 15 volt pull-up, but otherwise it's almost the same. And there is a bit of difference between how this is built and what propagation delays and so on for the 7406 and 7416. But for 99% of the purposes, they are totally interchangeable. And I'm going to see this in regard, as I said, of the Mini Pro programmer, and it's the TL866II Plus version that I have. And I do strongly believe that this is an original unit, so yours probably should look something like this if it's legit. And this has a rather comprehensive logical test. If we test this with an 7405 and select that from the list, you will actually get all vector testing, and this is a spelling error that's present in all the versions of the software. It's NURAML instead of normal, but that's just how it is. If I do a 7405 auto find, they also say that they have found just one chip and matched this. As we saw earlier here, the 7405 has the same pinout and almost the same kind of output as the 7406. So how does the Mini Pro programmer difference and see what chip is connected? Because the Mini Pro programmer, it only detects the levels. It's no timing or other things involved when the programmer actually detects if a chip is bad or not. It is this truth table where it tests all the variations on the inputs and outputs on the lines that determine if a chip is good or bad, or to do the auto detect. If I do a 7404 test, you remember a 7404 was a normal inverter with totem pole output. It also tests just fine. And the difference in the truth table here is that since the 7405 is an open collector circuit, it actually stands as C here. And it's not for sorrow, it's for high impedance. And that's because this chip cannot have a current on the output without a pull-up resistance or some other device that will provide this resistance. But when you put a 1 on the input, it actually will go low. So this is how the 7405 tests, and this is how the 7404 tests. It actually has a high when you put a 0 on the input. But if you put an auto find on the 7404, you actually find a lot of hits, and one that is rather surprising, or two that's surprising to us. The 4069 is actually a CMOS chip, and it has the same pinout as the 7404, so that's understandable, because, as I said, this just tests the high and low levels in logic, 5 volts or 0. But you also have here the 7406 and the 7416, and as we remember, these were open collector pinouts as well as the 7405. And if I test just with a 7406 inside, that is an open collector, you find that it matches with a 7405, and then you do a test on this as a 7406, it actually tests bad. So if you auto find it, it thinks it's a 7405 that has the open collector output as well. But if we actually select the 7406 from the list and test it, you see that the truth table that's put inside here for its 7406, it's not a high impedance output, it is a high output. The 7414, actually just as the 7404, it gets up the same hits here. And it also tests okay and have the truth table that is totally identical to the 7404 chip. But if I put a 7416 in the tester and do the auto find, it detects this as a 7405. That's, as you remember, an open collector variant. And if I do select the 7416 and test, you also get a fail here, because this also has a high on the output instead of the high impedance that you should expect for open collector chip. So that means if you put a 7406 or 7416 in your programmer and just test them, you will get a fail. And that's what makes me wonder how many people out there has actually tested one of these chips in the MiniPro programmer and just concluded that the chips was bad and just replaced them. Just for fun, I tested a 4069 CMOS chip and it tested just fine. AutoFind on this also takes the same list of chips as it did with a 7404. Then what? And I was thinking maybe there is a way around this, and there actually are. You can make your own profile in this software. So if you hit new here, you can actually make your own. You also have a copy feature, but we will test the new feature first. This is the profile of the 7405 that was in this program at once. And as you remember, if you auto test 7406, that's totally okay. You will get this truth table with the sets here. So you just select here what you should call your finished model. You select how many pins you should have, and then you select what pins should be what according to the truth table you want. And as you can see, 1 is an input, 2 is an output, 3 input, 4 output, and so on. So the first line in the truth table is 0 set, 0 set, 0 set, and you have the GND or earth connection on 7, and you have the VCC on 14. And then you just continue here with O set, O set, O set, and then you push new line. And when you put up a new line, you will see that this line is actually stored up here, and you continue just to put in the truth table, and now it's the 1 on the high on the inputs, and then you get low on the outputs, and the ground and VCC of course stays the same. So now you just choose to save your device, and when you then do a auto find with a 7406 plugged in, you actually get two logic matched. You get the 7405 that has the right truth table. It's defined as an open collector circuit. And you also get the one we made. If we do a test with manually selecting the 7406 chip and use the test button instead of AutoFind, we get the truth table here, and it actually tests quite normal. And as you can see, this is the original 7406 profile that the MiniPro programmer tests this with originally. And you can see here we have swapped the highs with C's here on all these. And then it tests OK. So when I test this OK, you get that all vector testings are normal. I actually wanted to fix also the 7416, so now I use the copy feature. And I choose to copy, and I already selected this device and push copy. And then you have the truth table ready-made when you get further, and you have the pins count also ready-made. So I just made a new name for this, the 7416 Coiro version, and save new. And then when I do a auto find with a 7416 inside, I get all the 3 chips that has the open collector outputs in the list. So if I test chips and use the right profile, I will get that they are okay. If I choose the original 7406 or 7416 profile, they still test bad. But this has helped us, and this probably will help you too, to not just throw away all your 7406 or 7416 chips. They are okay. Just some pages from the TTL Cookbook. They have a better explanation and a more common language on some of the descriptions. First, an explanation why this is called hex inverters is because they have 6 standalone inverters in every package. So every one of these is called hex inverters. And they have the rather simple explanation. Any one inverter, the low input condition drives the output high, the high input condition drives the output low. And this kind of simple explanation goes on throughout the TTL cookbook. It's a very, very good book. It explains every aspect you need to know about all the gates, all the counters, all the flip-flops, all the buffers, and all the shift registers, everything. Display drivers, yeah, you name it. It's covered in some fashion in the cookbook. And here we have just listed the others devices, but they also have an explanation of the hex-Schmidt trigger. And here they explain that the input processes a snap action used to condition slowly changing or noisy inputs. The input impedance of the circuit is about 6 K. The trip point for a positive going signal is 1.7 volts, so it's lower than a normal TTL. And the trip point for a negative going signal is 0.9 volts. So that means when the signal goes down, it's not triggering negative until it reaches 0.9 volt. Yeah, so the snap action or hysteresis range is about 0.8 volts. And this differs a bit if it's a 7414 LS or so on in this. That really was what I intended to cover in this video. So thanks for watching. Hope you enjoyed the content. It's a bit different from what I've covered lately, but this was a topic I really wanted to cover after I discovered that the MiniPro programmer actually tested these chips as faulty when they was not. So click like and subscribe if you want. Hope to see you in the next one. Thank you for watching.